All right, ladies and gentlemen, today is September 3rd. Today we are talking about simplifying variable expressions. This is for my pre-algebra class. Please go to page 8 in your notebook. Make sure you label page 8 with the page number and the date in the upper outside corner, as always. And your title today is Simplifying Variable Expressions. The objective, what you should be able to do before you leave class today is I can simplify variable expressions by using the distributive property and combining like terms. You need to be able to do both of those things before you're done with this video. Take a minute, pause if you need to, so that you can write down that objective. Okay, so as we get into talking about simplifying variable expressions, we have to talk about some definitions. There are a lot of them. There are terms, coefficients, constants, variables, like terms. You need to know what each of them means, and you need to be able to not mix them up. So, just like last night's video, understanding this video is not enough. You need to be able to memorize it. So if you need to practice, quiz yourself, whatever it takes, you need to know these. So a term is just the part of an expression that is added together. So for example, if I have 3x plus 4 plus 2y, I have this term, 3x, I have 4, positive 4, which is a term, and positive 2y. If there's nothing in front, like we have here for this 3, it's assumed to be positive. So terms, the part of an expression that are added together or subtracted. Like terms. Different than terms. A like term are any terms that have the identical variable parts. You are allowed to add like terms together. You can't add terms together unless they have the same identical variable parts. So an example of that, if I have 4x plus 2x, their variable is exactly the same. Therefore, I could add them together and get 6x. But wait, what happens if I have 4x squared plus 2x? Those are not the same variable part. They are different. One is x squared and one is x. They cannot count as the same. For this expression, it is as simple as it's possible to get it. You cannot simplify this anymore. Keep that in mind. Identical variable parts. A lot of people made the mistake with distributive property when we were talking about it in class today of, let's say we have this problem. They would distribute it properly. They'd end up with 4x plus 4, but then they would try and say, okay, well, that equals 8x. No, that is wrong. You cannot combine these terms because they are not like terms. They do not have identical variable parts. One has an x, one has no variable. Okay? Memorize those definitions, folks. You need them. Okay, moving on. More definitions. The coefficient. The coefficient of a term is the number part of any term with a variable. Let's look at some examples here. This is a term, 3x. It has a variable. The number part of that term is 3. So your coefficient is 3. Over here, take a minute, try and figure out what the coefficient is. Should have gotten -5. The coefficient over here, don't get confused because it has 3 different variables. That's okay. That is the variable part of the term. The coefficient here is the number part, so it's going to be -17. This one right here messes a lot of people up. Why? I like to think of mathematicians as being pretty lazy people. In fact, they're so lazy that they don't want to take the time to write 1y. Because in reality, y is simply 1y. But they don't write the coefficient because they're lazy. Since you are all becoming mathematicians, you shouldn't write it either. If you end up with a problem that has 1y in it, leave the y off. But you do need to know that if you see y, your coefficient is going to be 1. Okay? All pretty simple so far. Quiz yourself to make sure you understand them. Constant term. Another vocabulary. This should all still be on page 8. Write small if you need to. A constant term is a number that doesn't have a variable attached. So like a 10 or a 3 or a 1/2. Those are all constant terms. They don't have an x or a y or a z or an l or anything. Constant terms. All of your expressions are made up of these different pieces and parts. Terms, like terms, coefficients, variables, and constant terms. Please go on to page 9 and put your appropriate heading for page 9 on there. And I want you to actually write this full page out. I want you to write this part up here. List the coefficients, terms, like terms, and constant terms on the assigned lines. Because you're going to see questions just like this on a unit assessment. And I need you to be able to really be familiar with what they're asking you to do. First of all, you might notice that the expression I have up here has subtraction. Before you do anything, guys, anything at all, change subtraction to addition. So we're going to go through and rewrite this. 6x, instead of -2, we're going to turn that into plus -2. Plus 4x plus 6. Please do that. Don't think you don't have to. You do. When it asks us to list the terms, remember that terms are just all the parts of an expression that are added together. So my first term is going to be 6x. Put a comma. My next term is right here. It's -2. The reason I asked you to change this subtraction to adding a negative is that a lot of people try and just put 2 as a term. But it's not 2. It's plus -2. Don't forget that. We also have 4x and we have 6. Those are all of our terms in the problem. Let's look at coefficients now. Coefficients, remember, is the number part of a variable expression that of any term that has a variable. Sorry. So here we go. We have 6x here. That has a variable in it. The number part of that term is 6. -2 does not have a variable, so we do not list that as a coefficient. 4x has a variable. The number part of that variable, the coefficient, is 4. And then if we look here at 6, that also does not have a variable, so we do not include that in our list of coefficients. Moving on. Like terms. Like terms are the terms that have the exact same variable part. I like to use different colors to color code my expression. It helps me make more sense of it. So let's take a look at this first term, 6x. Are there any other terms that have the identical variable part? The clear answer is yes, 4x. So some like terms I have are 6x, 4x. Okay? Go ahead and separate that from other like terms. You can draw a little squiggly line or a semicolon or anything that helps you. Because we also have -2, and that like term, its partner, is plus 6. So over here, write -2 and 6. Those are our like terms. All right? I'm going to go ahead and erase this. Last thing it asks you to do is to identify your constants. If we look up here at the terms that we listed, our constants are -2 and 6. Constants are the number that do not have a variable. Okay? Do you have all that down? If not, pause, because we're moving on. All right, this example, I am going to give you about 5 seconds or so in the video. Go ahead and pause it and try and figure out what the terms, coefficients, like terms, and constant terms are in this expression. Make sure you pause the video. Okay, so you can see that I have put the answers up on the screen now. Double check that your answers match my answers. Couple things I want to point out, common mistakes. First of all, this minus 13, you should have changed it to plus negative 13. Another one is this coefficient of negative 1. That is paired with the negative n term. Remember, mathematicians are lazy. So instead of writing negative 1n, they just write negative n. But in reality, that coefficient would be negative 1. Like I said, double check that you got the right answers. If you didn't, pause the video and figure out what went wrong. Okay? Here we go. Moving on, I would like you to go to page 10, please. Page 10. And as your title, I would like you to write simplify. Examples. Now we're going to get into the combining like terms part of this lesson. We know what a like term is, we know how to find them, and now we're going to simplify expressions using like terms. All right, let's take a look at this first example. Go ahead and put this first on your page. And before you do anything else, I want you all to change any subtraction to adding a negative. So this is going to be 2x plus 15 plus negative x plus negative 3. Then go in with a different colored pen or a highlighter or a colored pencil and find your like terms. My first term is 2x, and I need to find a term that has the identical variable part. And that term is right here. When I'm combining these terms, I need to think of it as, very simply, an addition problem. 2x plus negative 1x. Remember that the hidden coefficient is 1. When you're combining like terms, you take your coefficients, in this case 2 and negative 1, and add them. 2 plus negative 1 is just going to be positive 1. Then you keep your variable the same. So 2x plus negative 1x equals 1x. But of course, I'm a lazy mathematician, so I'm just going to write x. With me so far? Next, I look at my other terms. I have plus 15 and negative 3. So I'm going to write this down, 15 plus negative 3. And I'm going to use my rules of integers and know that 15 plus negative 3 is going to be positive 12. So my simplified expression here is x plus 12. Pause it, rewind it, if you think you need to look it over again. Let's go ahead and do another example now. This time, I'm going to leave this example up on the board for a few seconds, pause the video, and try and figure out yourself combining like terms. All right, I've got my answer up here on the board. 6n plus 12 is the answer you should have come up with. If you didn't get that answer, pause the video, look at the work I did, and figure out what went wrong. I just want to mention again, you do not take this expression and then say, okay, that equals 18n. You cannot combine these two terms because they do not have the exact same variable part. Okay? All right, I'm going to do one more example real quick. I'll give you another chance to get it right. Hang on. I'm going to pause the video and put the correct answers for each of those on the screen so you can get the practice that you may need. They'll be back up in just a minute. All right, I've shown the solutions to these two questions up on the screen. Check your work, find out if you got the answers correct or incorrect. And if you got it wrong, take a look at my work. A common mistake that people may have made, over here on the right-hand side, I have, whoa, what are you doing? That's weird. Ignore those boxes. Over here on the right-hand side, I have a term with an n and a term with an x. Those are not identical variable parts. So you'll notice my final answer has a term with n's and a term with x's. You can't combine them. If you didn't get those right, go back, check, see what you did wrong. All right, simplifying an expression with distributive property. Guys, I think you should already be able to do this. This shouldn't be too difficult after what we did in class today. So I'm going to go ahead and ask you to pause the video, try and figure it out, and then check your answer. One thing I want you to remember is distribute first, then combine like terms. All right, guys, when you distribute first, you end up with negative 14r, because you take negative 7 times 2r and negative 7 plus 3, you get negative 14r plus negative 21, and then you have this 11r on the side. If you combine like terms, you should end up with negative 3r plus negative 21. Okay, that's just how you simplify with distributive property. Make sure you know how to do that. That is going to be one of the questions on the questions of the day tomorrow. We're going to skip that. Here we go. I really, really like this one. Please go to page 11, and I want you to draw everything that's up on the board. I actually want you to write the problem for this one, and I want you to draw the triangle. This is the kind of question that Common Core loves. Remember, Common Core is the new set of state standards. They like to give you more challenging questions, more real-world questions. They're not just going to give you 6a plus 2 plus 4a plus 7 and ask you to simplify it. They're going to give you a situation like this, where you have to not only understand how to simplify an expression, but you have to understand what perimeter is and what perimeter means. So they're going to look for you to have all of those skills. If you need to pause to copy the triangle, please do so now. A quick review. Perimeter is the distance around an object. So if I am going all the way around this triangle, I am going to add up the lengths of all my triangles. In this case, my triangle lengths have a bunch of variables. That's okay. You're going to treat it exactly the same. I'm going to take my first side, 3a plus 2. Add that to my second side, plus 4a. Add that to my third side, plus 6a plus 7. I have now written an expression to represent the perimeter. If I take that now and I simplify it, I combine like terms to simplify this, I'm going to circle my first term of the problem, that's 3a. I will now look for any other terms that have an a in them. I've got 4a and 6a, and I'm going to add that all together. 3a plus 4a plus 6a, and that's going to give me 13a. I will do the same thing for my constant terms. I have 2 and I have 7. 2 plus 7, that's going to give me 9. So my expression for the perimeter of this triangle is 13a plus 9. The reason this is so helpful to be able to do this kind of math is because they might give you a problem that says, hey, this triangle has a perimeter of 103. Please find out what a equals. You can write your expression, except now set it equal to 103. You can combine your terms, still set equal to 103, and then you can actually use algebra to solve the equation. Then this problem would hit on not only your understanding of perimeter and your understanding of combining like terms, but it also requires that you understand how to solve a two-step algebraic equation. Test makers love questions like that hit a lot of different things. If we look at this example, I want you to try and figure this one out. I want you to pause your video and see if you can solve this. I'm going to put the answer up in just a minute. I really like problems like this, guys, because there's two different ways to approach it. You can either recognize that this top length of the rectangle is also 5y minus 3, and this side is 3y, and then just do a simple expression adding all the sides together, you would end up with 16y plus 6. Or you can know that the perimeter is the length plus the width, which I have represented right here, times 2. Look, there's my 2. I can then go in and simplify what's in my parentheses, end up with 8y minus 3, then distribute my 2, and take a look at that. I get the same answer. You can do it either way. All right, guys, I think that's about it for the day. Yep, that's as far as I want to go. So make sure you take good notes, review the video if you need to, and I will see you tomorrow in class. Thank you.